Hello and welcome back. In this video, I'm going to work through an example of finding the distance between a point and a line. All right, so remember we have our point Q, which is not necessarily on the line, and then we have our line here, which is given by t times 2, 1, 2. So notice that this passes through the origin, right? T equal to 0. If I set t equal to 0, I get 0, 0, 0. So that means 0, 0, 0, that point, the origin, is on the line. Now that's a pretty nice point to use on the line. Remember, any point is going to work. I just need to get some point P that's on the line. In this case, 0, 0, 0, the origin is sort of the easiest thing to use. So if you do have a line that goes through the origin, use the origin as your point P. And then remember that the distance between the point and the line, if I can find any point on the line P, I can find the vector between P and Q. And then I don't want to find the magnitude of that. Rather, I want to take the cross product with my direction vector V and then divide by the magnitude of my direction vector V. So let's see, my direction vector V can be recovered. It's the coefficient of the t in the vector equation of a line. So my direction vector V is the vector 2, 1, 2. So now I can, let's find the vector PQ. Well, P is 0, 0, 0, so PQ is just the position vector for this point, 1, 0, 3. So I'll write here PQ. Again, I keep stressing this, but I want to stress it sort of every time I do it. Break down the big calculation. So we have this big task to do. Find the distance between a point and a line. So we need to think about what do we need, what sort of figures, numbers, what do we need to find that. In this case, I've remembered the equation of it. I need PQ, V, and I need to compute the cross product, and then break that down into smaller tasks. So I first found expressions for my vectors in my equation. Now I'm going to start using, I'm going to start actually performing the operations in this equation. So one thing I need to do is do PQ cross V. So let's calculate that next. So PQ cross V. Well, I have both of those. That's 2. I don't want to go in the opposite direction. It's not going to matter because I'm taking the magnitude, but let me just keep this. Remember that order is important for the cross product. 3 cross 2, 1, 2. And let's see. So let's find that cross product. This is the determinant of the matrix I, J, K, 1, 0, 3, 2, 1, 2. And I hope you're getting good at doing these cross products, finding these determinants. I'm going to go kind of quickly here. So my I component, 0 times 2 is 0, minus 3. So this is going to be minus 3i. My j, remember my j gets negatized. I end up negating this term here. So when I do j, I'm going to have 1, 2, 3, 2. So that's 2 minus 6. That's negative 4, but then the j is a negative, so this is going to be plus 4j, right? Remember, you always flip the j term when you're expanding along the first row. And then for the k term, I have 1, 1, 0, 2, so 1 times 1 is 1, minus 0, that's 1, so this is just plus k. And I'll write that in vector form, negative 3, 4, 1. So that's my cross product. Let's go ahead and find the magnitude of that. So again, breaking this down into smaller steps. I first computed the cross product. Now I'm going to compute the magnitude of that cross product. Please don't come up here, kitty. Come on, kitty. All right, thank you. Sorry. 3 squared plus 4 squared. Because now that I actually have the vector, it's easy to compute the magnitude. I don't want to do that sort of at the first. You might use the wrong, or you might use an expression that involves having to find the angle between them, and doing dot products. It'll be a whole mess. Break it down into steps like this. So that's going to be square root of 9 plus 16. That's 25. It's 26. Square root of 26 is my magnitude of the cross product. Great. And then magnitude of V. I could have done that earlier. That's okay. I'll do it now. That's going to be square root of 2 squared plus 1 squared plus 2 squared. So that's 4. That's 8. That's 9. That's square root of 9. That's 3. Okay, so that means my distance then is square root of 26 over 3. Isn't that neat? You can do this sort of trigonometric, geometric type problem just by using vector operations, just by using this formula, which just involves, right, this cross product operation and dividing by a magnitude. It's pretty awesome. At least I think so. I hope you kind of think it's cool as well that we can encode all of this sort of geometric, trigonometric stuff just in algebraic operations between our vectors. This is highlighting the power of vectors and these operations between them. So there's our distance. All right, that's it for this video. I'll see you next time. We'll start talking about planes.